Dear students, in the last video we studied the example number 1.5. Now in this example we are going to see the example number 1.6. See the given things in that example, in this example, that is the square is given and on the vertices of the square A, B, C, D are the vertices of the square having a side of 10 centimeter, and on the vertices of the square the charges are kept. QA, QB, QC and QD are the charges kept on the vertices. So we are going to write, see here on the vertices there plus 2 microcoulomb charge is kept. On the B vertices minus 5 microcoulomb charge is kept. On the C, that is plus 2 microcoulomb charge is kept, and on the D vertices again minus 5 microcoulomb charge is kept. The question is find out the force acting on the center of the square, and on the center of the square there is a 1 microcoulomb charge is kept. See what is the question? Find out the force acting on the center of the square due to the 4 charges. Force acting on the central part, and on the central part there is a 1 microcoulomb charge is kept. First of all we will write, or we are going to find out the direction of forces due to individual forces. See, this is the square, means we can say that distance of A to O, this AO distance is same or is equal to DO distance, which is also equal to CO distance, and which is also equal to OB distance, right? So distance of O from the A, from the D, from the C and from the B will be same as it is a square, correct? First of all, what is the force acting on central part due to the A? It is the plus, it is also plus. So force will be a repulsive force, and that will be directed like this. So force acting on O due to the A, this will be the direction, right? Similarly, what is the force acting on O due to the C? It is also plus, it is also plus. So this will be directed like this, right? So this is the direction of force acting on O due to the C, right? So these two forces are equal in magnitude and opposite in direction. They are opposite in direction, that we can easily see. How we can say that they are equal in magnitude? Because the distance of OC and the distance of OA is the same. That's why the FOC and the FOA is the same, right? First of all, here we will write here the OA which is equal to OA, which is equal to DO, which is also equal to CO, which is also equal to BO, right? And that is equal to R, that we can write, correct? Now, what is the force acting on O due to the A? Force acting on O due to the A, and that is equal to K, the first charge Q, that is, suppose we are writing QA, right, into QB means this, right? We can suppose we can write this charge as a Q or capital Q, or Q0 we can write, right? Q0 denoting central charge, suppose Q0, right? Q0, and distance is R square, correct? So this is the equation number 1 we can see. Now what is the force acting on O due to the C? That we will write. Force acting on O due to the C. We are going to calculate the magnitude. So K, force due to the C, that is QC, and force acting on charge on the central part, that is Q0, and distance is R square. This is the equation second. In the equation 1 and 2, what we can say that the QC and QA, what is QC? See, what is QC? 2 microcoulomb. What is QA? 2 microcoulomb. So in equation 1 and 2, in equation 1 and 2, the QA equal to QC. So QA equal to QC, hence we can say that by observing these two equations, all the terms are same. So that's why the force acting on A due to the force acting on O due to A, this FOA and this FOC are equal in magnitude because they are at the same distance, right? So here we will write like this. They are equal in magnitude. So we will write if the two forces are equal in magnitude and opposite in direction, so FOA equal to minus of FOC. They are equal in magnitude and opposite in direction. So this is the equation number 3 we can write. They are opposite in direction. Correct? Now we are going to take another pair. See the diagram once again. We discussed the pair, right? Now we will discuss this pair, the point D and point B. See from the diagram what we can say that what is the force acting on O due to the D, right? Here the D is minus 5 microcoulomb. It is a plus. So what we can say that there is a attractive force will be present. So this is we can write. So this is the force acting on O due to the D. Similarly, this is the plus Q charge, this is the minus Q charge. Again the attractive force will present. So at the center the force will be attracted towards the B, right? So we will write like this. So force acting on O due to the B. So what is about FOD and what about FOB? They are also equal in magnitude and opposite in direction because the distance of DO and the distance of BO is the same and direction is opposite. So we are going to calculate the magnitude of FOD and the magnitude of FOB. See, now force acting on O due to the D, that will be K, charge due to the D, right, and charge on the center divided by R square, equation number 4, and force acting on O due to the B, right, that is equal to K QB, right, and QO means charge on the center, that is R square, equation number 5. In the equation 4 and 5, we know that, see, the QD and QB are equal. See the diagram. This is minus 5 microcoulomb. This is also minus 5 microcoulomb. So QD and QB are equal. So here, but QD and QB are equal. Hence equation 4 and 5 are equal in magnitude, right? So the force FOD and FOB are equal in magnitude, right? And they are opposite in direction, that we have already seen in the diagram. So therefore what we can write, FOD equal to minus of FOB, equation number 6. Now you just concentrate on equation 3 and equation 6. Now the total force on O, એટલે center. So force on O due to A, force on O due to B, force on O due to C, and force on O due to D. Now please concentrate. FOA remains, FOA equal to, we can write minus of FOC plus FOB equal to, we can write FOB remains suppose as it is, FOC remains as it is, plus FOD equal to, we can write minus of FOB minus of FOB. Here this minus, this plus get cancel. So this get cancel, it is minus, this plus get cancel. So resultant force acting on the O will becomes 0. Addition becomes 0. So here FO equal to 0. Resultant force acting on the central part will becomes 0. Here is the end of your numerical. You just take the screenshot and we will move towards the next example. Example number 1.7. Okay students, see example number 1.7, that is a theoretical one, and electrostatic field lines is a continuous curve, that is field lines cannot have sudden breaks. Why not, and explain why the two field lines never cross each other. Dear students, that we have already studied when we have studied the characteristics of electric field lines. So this is the homework for you. You just try to write in your own language the answer of example number 1.7. Now we will see the example 1.8. You just read the example 1.8. Here example number 1.8. See what is given. 2 point charges 3 microcoulomb and minus 3 microcoulomb are located 20 centimeter apart in a vacuum. What is the electric field at the midpoint of the line AB joining the two charges? This is the first question. Next question we will see in the next part. See 1.8, two charge particles QA and QB, that is 3 QA equal to 3 microcoulomb and QB equal to minus 3 microcoulomb. They are separated by distance 20 centimeter. So distance 2A, distance between the two charge particles, that is 20 centimeter. From the center, this is the central part, center to A, that is 10 centimeter. Center to B, that is also a 10 centimeter, means 0.1 meter we can write. The question, the first question, find out the electric field at the O due to the first charge and due to the second charge. Simple question. I am repeating the question. Find out the electric field at point O due to the A charge and due to the B charge. Dear students, we know this is the QA. We know that it is plus 3 coulomb, plus Q charge is present. So due to the plus Q charge, the electric field lines are going away. So at point O, the direction of electric field at point O, direction of electric field due to the A charge will be like this. So this is the direction of electric field at point O due to the A charge. So we will write electric field at point O due to the A charge. Similarly, this is the minus 3 coulomb charge, as we know that it is a minus 3 coulomb charge, QB equal to. So minus means what? The electric field lines are coming towards the minus Q charge. So what is the electric field at point O? Due to the minus Q charge, that will be again towards this minus Q charge. So it will be like this, electric field at point O due to the B. So the plus and minus, this plus and this minus help us to find out the direction of electric field at point O. The role of plus and minus is ends over here. What I am saying, the role of plus and minus is to find the direction of electric field at point O. Now in the numerical we will put the values, or we will put the magnitudes of charge. So at point O, the total electric field, that will be electric field at point O equal to electric field at point O due to A, electric field at O due to the B. Right? Why we are adding? This is the question. Why we are adding? Because the direction of electric field EOA and EOB are in the same direction. That's why we are going to add EOA and EOB. Correct? We know the general formula for electric field, E equal to KQ divided by R square. Q is the source charge. So electric field at point O due to the A. So this will be the source charge at point O due to this. So KQA divided by distance of O to A, that is OA bracket square, plus electric field at point O due to the B charge, that is KQB divided by OB square. Here OA and OB are same. Here OA equal to OB, right? And QA equal to also QB, right? So we are going to take the magnitudes only. So K remains, suppose over here 9 10 to the power 9, QA equal to 3 microcoulomb divided by OA. OA means this distance, 10 centimeter. We are going to convert it into the meter. So 0.1 meter square plus K remains, that is 9 10 to the power 9 into QB. We are going to take the magnitude only, 3 into 10 to the power minus 6 divided by 0.1 bracket square. Means it is the 2 times we can say that, right? So this and this is same. So 2 times we can write, and see how we can write this. EO equal to 2 times 9 10 to the power 9 multiplied by 3 microcoulomb minus and divided by 0.1 bracket square, right? After solving this, you will get the answer, and that is near about 5.4 10 to the power 6. 5.4 10 to the power 6 Newton per coulomb, and the direction of electric field is towards the B charge. Direction of electric field is towards the B charge, QB charge, right? The second part we are going to see, it's very easy. In the second part, what is given? The charge of 1.5. Let me confirm. Negative charge, Q equal to minus of 1.5, minus of 1.5, 10 to the power minus 9 coulomb charge is kept over here, right? So see the diagram once again. If we draw the new diagram for the B part, we are going to draw the new diagram. See, this is the QA, this is the QB, right? So it is a QA means 3 microcoulomb charge, right? 3 microcoulomb. It is a -3 microcoulomb. Center, on the center, -1.5 10 to the power -9 coulomb charge is kept, and find out the direction of electric field and magnitude of electric field at O. This is the simple question. The charges are same, so electric field will be this EO equal to 5.4, but we are going to calculate the direction of what is question, that is find the force acting on O. Find the force acting on O. So F equal to, we can write Q into E. So what is the charge kept? That is this Q charge is kept. So F equal to, what is the value? We are going to take the magnitude 1.5 into 10 to the power -9 multiplied by electric field at point O, and that is equal to 5.4 10 to the power 6. So answer will be, the answer will be near about 8.1 10 to the power -3. 8.1 10 to the power -3 Newton. This is the force acting on O, right, due to this. Now the question is for direction. Last we are going to think over here. See, the charge is minus charge is kept over here, minus charge is kept over here. It is a plus, it is a minus, so direction due to plus and minus will be again attractive one. So at O, the direction of force will be in this direction. It is a minus, repulsive force will present. So due to this here, the repulsive force will present. So at point O, the direction of force is towards the plus Q charge. So we will write direction of, in the second part, direction of force is towards the QA charge, right? We must have to mention the directions. These directions we have to mention, right? So here is the end of this numerical. Dear students, in the next video we will see the next numericals, right? Thank you. I just take the screenshot first. Okay, thank you.